Good afternoon, matriculants, colleagues, friends, and fanatics. Let's have a look at some consolidation work now using past exam question papers, since we have gone through the sequences and series lessons nicely and as best as we could. Now, let's see how much applications or how many questions can we answer with ease, knowing what we know currently. Please take it upon yourself to practice as many past exam question papers from Term 1, Term 2, Term 3, Term 4, and please the May June exams as well. Just practice everything on this topic on as many past exam question papers as you can find. Don't worry about the number per se, but as many question papers as you can find. Go through these questions. Of course, I'll pick some nicer ones and discuss with you to show most of the knowledge you should already possess and how to use it in answering these questions. So we're going to take this one from the Northwest Province. This was last year's Term 1 exam, okay? So, of course, guys, instructions are important. I'm not really interested in a lot of things, but in calculations, we need to show everything we have used in determining our answers. The etc. part is what most people pay less attention to, and yet it's key. All right? Of course, where it's necessary, we need to round off to 2 decimal places. So that's very important. Of course, guys, read all the instructions and adhere to all. But the most dangerous ones, if you don't pay attention to them, are those two. They will take you down, especially this one as well. It's a very dangerous one too. Of course, guys, algebra is always going to be present in Term 1 exams. It depends on the province, of course, on what was the content the provincial examiners wanted to put, but make sure algebra has been practiced, because this is nothing but grade 11 work. Maybe a small amount of grade 12 work can be included, but it's usually grade 11 and backwards, so kill this thing. Now, question 2 is exactly our target for the day. Question 3, again, sequences and series, is exactly our target today. Of course, we did not discuss the sigma notation as yet, but I don't think it's that important, is it? You guys should know how to deal with sigma notation. Your teachers have taught you that. I don't think there's any passion in me in showing the sigma notation, but perhaps I will do a lesson on sigma notation just to highlight a few things, but I do believe you already know those. And in fact, watching this video, you'll understand these kind of things. So I don't think there's any need for me to do that. Then, of course, previously there was Euclidean geometry. I'm not too sure if it is still coming back. Question 5 is still Euclidean geometry. I'm not too sure if it is coming back. Very nice questions otherwise. But question 6 is definitely part of your next exam, as in the Term 1 exams. Trigonometry is in your ATP, so of course they will ask it in different ways. I have already shown you how to deal with trigonometry in December, so if you took notice of what I taught you, you can then try your luck on those questions. If you get stuck, let me know, okay? And some of those of you who will be a part of my classes, the online classes, which I'm going to do, not so, should I say, I'm not going to be too much into that because I don't have time, but we will discuss certain questions, and perhaps these would be good for practicing even Euclidean geometry, because guys, grade 12 syllabus is over here, because what we need now is just financial maths, fundamental counting principles, calculus, differential calculus, let's put it that way, because it's not exactly the calculus as a whole, but differential calculus and financial math, which is nothing. Functions you already know, but maybe a bit more. All right, guys, let's not waste time. let's just get to the business of the day. We are starting and doing question 2. So this is the question we need to handle. Now let's deal. We are told to calculate the number of terms in the following arithmetic sequence. So we are told what this is. So 2.1, we've got an arithmetic sequence. Perhaps it's best to say AP, arithmetic progression. So we've got 6, 1, minus 4, minus 9. This continues until minus 2, 3, 9. Since this is an arithmetic progression, we know that there's going to be a common difference. So 1 minus 5, so minus 6, it's going to be minus 5. So this should be our common difference because we were told this is an arithmetic progression. If we didn't know that, we would have to check. But now we know. So we don't complicate our lives. So what are we doing? We want the number of terms. But remember, this is term 1, term 2, term 3, term 4. This is Tn because we don't know this. But knowing that this is from term 1, I don't know why I wrote Tn there. Since we know this is from term 1, it means finding the position of this term is essentially finding the total number of terms. So what do we know, guys? We know that Tn is equal to A plus n minus 1 times D. We need to always show the formula. Now Tn is minus 239 equal to A is the first term, which is 6 plus n minus 1. D is minus 5. Okay, this implies further that minus 239 is equal to 6 minus 5n plus 5. This also implies that, now guys, I'm gonna take, okay, let's just simplify without rushing. 5 plus 6 is 11 minus 5n. I'm going to take 5n to the other side and 239 to this side. This implies that 5n is equal to, now 11 plus 39, we know that 1 is going to add there, it's 10. So that's going to be 40. 40 plus 10, that's 50. So this is going to be 250. So therefore our n is going to be, now 250 divided by 5. What is it? It's 50, isn't it? Because 5 times 50 is 250. So this is 50. Okay. Again, you can use the calculator to confirm in case there's a problem. But at times, certain things need to come naturally. But now, no one said calculate n, but it said what is the number of terms. So let's answer it. Therefore, there are 50 terms in the sequence. Okay, that's it. We were asked a question in English. We need to answer it in English. The math is a means to an end. Now we need to show the formula, guys. Without it, we don't know what you are doing here. So if you don't show us this dude, if you don't show what, this whole thing doesn't get a mark, okay? I am that kind of an examiner. Because it means you did not adhere to that instruction. Remember this instruction? It says, etc. We need to clearly show all our workings. And that means a rule or a formula, okay? So showing this, we know we can then mark the substitutions, provided they are correct, okay? And essentially, we will mark the common difference. Again, guys, you can list it, you can substitute it here, it's okay. That is essentially a mark. Great. Now, the final answer is what answers the question. So this is how we score our 3 marks. Let's move on. So the key here is writing the correct formula, doing the correct substitutions, and calculating correctly. Otherwise, you don't know how you're going to check this. It's not easy. But you can check it by finding out if there's 50 terms, you're saying that is T50. You just solve for T50 here using this formula. That's another way of checking. And if you get minus 239, that proves that we also got it right. Okay? Perhaps that's how you would check that answer. Now let's get to 2.2. It says now 2. Okay, let's read first. 2m12p are the first 4 terms of a quadratic sequence. Again, we need to know what that is. Great. Now we've got a quadratic progression here, starting from 2, going to m, going to 12, going to p, and it continues. Now we are told if the second difference, we know that the second difference is constant or it's common, we need to calculate the values of m and p. Now we don't need an invitation for this. We know that between these two we will have m minus 2. Okay, and between these two we're going to have 12 minus m. Those are the first differences. We've got p minus 12. And of course, this is a sequence on its own. It will continue as long as we have that. But we are told the constant second difference is a 6. So it should be the case also between those two, because we know that this is a constant common difference. Constant second difference. So again, this structure, guys, needs to be understood. And what is the key here? We know that we understand that 2a is given by this, right? And we also know that 3a plus b gives us this very first term of the first differences. And we know a plus b plus c gives us that very first term of the quadratic sequence. Again, these are very important issues to keep in mind as we solve, because we studied these and explored them and established that this is what helps us. Okay, now we're not going to waste time. What is the question? We need to find m first. So we know that essentially 12 minus m minus into m minus 2 is a 6, because it's a quadratic sequence. So this implies that we have 12 minus m plus 2 equal to 6. Essentially, we have minus 2m is equal to, this is 14, we transpose to the other side. Now 14 minus 6 is 8. So it's minus 8 because it's going to be minus 14. Therefore, m is 4. That's an intermediate answer, but again, it's an answer because that was a question. Now let's do the next one right here to save our space. My lines like to slant, guys, like seriously. Anyway, we also know that essentially p minus 12 minus into 12 minus m should also be equal to 6. Now, as you can see, guys, this is what we are doing. The first one, we're taking these second differences from there, and the next one we are taking it from here. So it's always nice to understand what you are doing so that you can work it out. So this is going to be p minus 12 plus m. Okay, maybe let's just substitute before we rush into problems. m is 4 equal to 6. Then we deal with the brackets, because remember, brackets, we need to deal with what is inside before we can start doing things, or else we will find ourselves in trouble. Alright, so from here, guys, I don't see any point in delaying this. We can see that P is going to be, now this is minus 24 plus 4, that's minus 20. Then we bring it this side, it becomes 26. Easy, né? Yes. Now we have sorted that question. So where are the marks here? Obviously this equation was not given. The rest of the gymnastics are what is expected because we are applying algebra here. And then the second one, the substitution that is correct over here. And the entire equation, I mean, we can mark it here as well because we were not given that equation. And the final answer. That gives us a total of 5 marks. Nice and easy. Okay, let's move on to 2.3. Now 2.3, we need to consider a geometric series. We are told what it is. So we've got a G as 2 into 3m minus 1 plus 2 into 3m minus 1 squared plus 2 into 3m minus 1 cubed, and we are told it continues like this. Now from observation, we will see that this part that increases somewhat exponentially. Can you see? The exponents are increasing from exponent 1 to 2 to 3, so this is the common ratio. Okay, alright, okay, because the 2's are constant or consistent, so this means as we divide, they will divide to 1. Again, inspection is important, guys, knowing what is important here. So we can clearly see that essentially here R is going to be equal to 3m minus 1. This you can prove by doing some calculations. In case you don't know, let me just show you on your rough work what is expected of you in this regard. So we could take the second term and say 2 into 3m minus 1 squared divided by 2 into 3m minus 1. We know that the 2 will divide the 2 to 1 and it essentially becomes invisible. 1 in maths can be considered as an invisible thing. This bracket takes the exponent and leaves just 1 because we could easily, this is to the exponent 1. When we take it to the top, it's to the exponent minus 1. Same basis, exponents add up, so that would be 2 minus 1, and we end up with this. So at the end of the day, what do we end up with? It's 3m minus 1. So this is part of the rough work, no part of the solution, okay? Easy. Now, what are we supposed to say? We are asked a question now. For which values of m will the series converge? Now, when does a series converge? When r is less than 1, greater than minus 1. We explored this in our lesson. So it's nicely easy to apply now. Okay, let's say for a geometric series to converge, it is such that r must be less than 1, greater than minus 1. Okay, now this implies what is r here? It's 3m minus 1 must be less than 1, greater than minus 1. This also implies, now we simplify, we just transpose 1 to either side. So one day it's going to be 1 minus 1, which is 0. Then we transpose this, it becomes a 2. Then we divide by 3 on both sides. 0 divided by 3, it's a positive number, it's 0, the sign remains, and that is m. And then we divide by 3 here, we get 2 over 3. Okay, that's good. We leave it at that. But the question, it says for which values. So this is the domain of the values of m that will make this series to converge. Okay, very easy, not a complicated story. Please know how to do these things, folks. It's very easy. Now, first of all, this setup, which is the correct substitution, noticing that r is like that was very important, and the final constraint gives us those 3 marks. Nothing complicated, and we just move on. So this was 2.3.1. I forgot to label, so the idea of me doing this is for you guys to learn consistency, because students, we know it, they tend to copy what they see, or they tend to assimilate what they are exposed to. So if I'm careless, you tend to be careless. So this is why I'm going to be as methodical as possible, so that you can appreciate this whole thing, so that you skip certain things knowing very well their significance. Okay, we asked a question now that we need to calculate the sum to infinity when m is a half, and we can see that a half is definitely less than 2 over 3, greater than that. So this is 0.67, essentially that's 0, and this is a half, which is 0.5. So this is in between those constraints, so this is good. So of course we know that the geometric series now is essentially 2 into a half minus 1 plus 2 into wait a minute, this is dangerous things. This is 2 into, this is 3m, so this is 3 over 2. Now when we multiply half here, minus 1, okay, so plus 2 into 3 over 2 minus 1 squared, plus 3 into 3 over 2 minus 1 cubed. And the sequence continues, the series continues. Now, there are 2 things that we need. We need the first term, and we need the last term, the common ratio. So what do we know? We know that essentially a is equal to 2 into 3 over 2. We could easily have done this and not wasted time writing out the sequence, but I was just doing it for your benefit after all. Therefore our a is, now multiply 2 there, that's 2, 3 minus 2, that's 1 over 2. A half multiplied by 2 is just minus 1. Okay, that's what we get. And then what else are we going to do? We are going to do this and say also r is equal to, we saw that this is just 3 over 2 minus 1. What is this? Multiplied there, this is just 1 over 2. Nice and easy. Now 1 over 2 is 0.5, isn't it? And 0.5 is definitely less than 1, greater than minus 1. So that category is maintained. Now we can answer the question. We can say, well, we know that sum to infinity is a over 1 minus r. Okay, we need to show this. This needs to be shown. Don't just jump in. Okay, at this point we follow the examiner's instructions. Sum to infinity is a is minus 1 divided by 1 minus a half. So therefore our sum to infinity is basically minus 2. Great. Easy? Very easy. It's very easy. If you say this is hard, come here. Let me break your jaw so that you don't go around talking nonsense, because you are spewing trash if you say that. Right. Now let's go. Finding the a value, finding the actual I value, correct substitutions into a structure, and an answer gives us the 4 marks. Very easy, guys. And that's the total of, essentially, easy 15 marks. Can you see? We learned these things. Now we can put them to practice, and you can see how very interesting this is, because you are a genius. You are a genius, are you not? You are. You are a genius. Okay, guys, let's move on to the next question quickly. Question 3. Now, I didn't speak about sigma notation, but we're going to talk about it now. We are given the sigma with n starting from 1 to infinity of this general term, 3m to the exponent n minus 1, and we are told this is equal to 189 over 2. So that's the sum, essentially. Great, and now we need to solve for m. Now from inspection, guys, we will see that in general, when we write in sigma notation, we know that we're going to have the sigma, which means sum, and then we'll have the general formula. Of course, if we're going to infinity, it already tells us that this is a geometric series. So this is ARN to the minus 1, right? Right. So we're starting from n equals 1 to n infinity. So this is how we write in sigma notation. It's always going to be the sigma sign to suggest that each term is added to the next. Then this is where we start in our general formula, and that's where we go. But remember, this is A, the first term. This is R, the common ratio. So if we compare, we will see that we still have the same story here. This is A. Now that means M should be the common ratio. Okay, because it fits exactly the formula right there. So we need to know how to look at these things, guys, because for me as a first student, because I took time to study things when I could, and then I started to make my own notes. Remember, notes is not just copying what's written. A lot of students miss the point of taking notes. I don't understand why people say they are taking notes when they are copying exactly what's written. Notes, guys, is what you deduce from reading. You understand? If you read a particular statement and you can see that it implies something not written there, that's a note. Shouldn't be writing what's written, because you can go and read it again. All you have to do is just to understand what's written, that's all. And if you understand it, you don't have to worry about it, isn't it? But hey, I don't know, a lot of you guys are taught the wrong way anyway, and you believe in that nonsense, and you continue with it until you crash and burn at university. Because at varsity, guys, oh my Lord, a lot of people study in a very poor way, and you can see when they come out. Yeah, you can tell. They may hold all those degrees, but they don't represent those degrees. Until somebody, a good Samaritan, in their workspace teaches them how to do the work. Then they start to learn the work. In fact, you just wonder, Shouldn't have they just gone to the job so that they could be taught by the person with the experience on how to work? Because going to school didn't really help them, did it? Back to diff. Anyway, guys, taking notes for me is essentially something you yourself noted. Okay? And you don't note something if you haven't understood what is given to you or what you see. So, notes is what you deduce. It's not what is written. Otherwise, you are reproducing the damn text. And that's a waste of time. Anyway, guys, nonsense aside, let's move on. Now, of course, some students are advised, in fact, I advise everyone who's not clear on the topic to do this with a sigma like that. We just have to extend it. We know that this is sum to infinity, which is such that, remember, we start by substituting 1 there. 1 minus 1 is 0. M to the 0 is nothing but 1. So it's essentially 63. Plus, because that sigma sign means it's a plus. We go on, substitute a 2 there. That's going to be 63M. Right? We substitute a 3. At least you want 3 terms so that you can identify what it is in case you don't understand. But I find it a waste of precious time. Now, once we have 3 terms, we don't care. We show that this goes on forever. But now, what is the total? It's 189 over 2. So, a very, should we say, student who's not so sure what they're looking at, because again, it takes confidence to be comfortable with what you see. You would do this and then, of course, find out that the common ratio is going to be 63m divided by 63, which would cancel that one. Not necessarily cancel, but divide into 1. 1 is essentially invisible, so when we multiply by 1, we have m, and that is r. Can you see? I already knew by just looking at the expression without wasting my time. I also knew that this is my first term, but just looking at the expression without wasting time. But hey, again, these kinds of things are not normally shown or taught. Sometimes students always fall into the trap of wasting time, extending this thing, and yet the very information that they're going to uncover here is already given. It's just doing it the second time. Anyway, I'm just showing you these things, guys, so that you don't go around looking like whatever. Anyway, if we're solving for m, what are we going to do? We just solve the sum to infinity. So we know that the sum to infinity, guys, is equal to, we are told right now that this is, but we're going to use the formula first to show that we understand what we are doing. Because without showing the formula, we are dead. We need to show the formula. Then we imply the sum to infinity is 189 over 2, which is going to be equal to the first term is 63, all divided by 1 minus m, isn't it? Cross multiply. What do we get? We get here 189 minus 189m will be equal to 63 by 2, that is 126. And we continue to try and solve the matter. Transpose the 189, there we get minus 189m is equal to 1. This is going to be 9 minus 6, that's 3. And then we're going to have 12 minus... Wait. We're going to take the difference, but the sign of the bigger number prevails. So 8 minus 2 is 6. So that is minus 63. Okay, great. And then we divide by minus 189, sorry. Therefore, m is equal to minus 63 over minus 189. Now we know that 63 goes once to itself, divided by, goes 3 times to 189. Again, if you don't know this, so bona later, because by is right. Anyway, anyhow, now of course negative divided by negative is a positive, so it's a third. Nice and easy. We've solved for m. So how do we score marks here? Of course, substitutions is very important. But now look at these marks, 4 marks. The second mark comes for the answer. But now where are the 2 marks? Is realizing the first term is a and the common ratio is m. So that's how we score our 4 easy marks. Provided we show the formula in operation, because if you don't show the formula, the rest of what you did here is gibberish. Because to me, as a marker, you have copied. I don't care if you are just trying to impress or you're saving time. That's not my problem. My problem is that I cannot prove you have not copied if you're not displaying to me that you did this by yourself, okay? Because there will always be an indication that this person is not doing the right thing. For example, if you find that the steps, there's a mistake, but they end up with the correct operation and the correct answer, that already tells me the student is copying. So be very careful. There's many ways of picking up chicanery. So don't practice chicanery. We will kill you, and kill you with a very big smile in our face. So don't do it. It's dangerous. So this was 3.1. Unfortunately, I forgot to label. Again, this is a bad thing because I need to show you guys how to get your job done. So 3.2, I say baby. If it is further given that m is a third, C confirms our answer. Now we know. Can you see sometimes examiners, when they know you're not going to be so sure, they actually provide that conviction. Even when you have gone wrong, sometimes when that is crucial, they help you to realize that, something went wrong. Let me go check. Is my answer on point? Where did I miss it? Anyway, I told you to, it is further given that m is a third. Now we need to determine the smallest value of n, such that Tn is less than 1 over 6,565. Very easy. Tn is a term, and we know this is a geometric series, so this is ar to the n minus 1. So this is what needs to come to mind. Okay guys, so please don't be careless, don't be in a hurry. Maths is very easy, guys. If you just stick with the rules, you learn the basics, you then realize things, meaning you're gonna take notes. Taking notes is not writing the rubbish or written already. That is plagiarism, and in fact that is tautology. Phinda-phinda. Why izophinda-phinda into? Sinaxesha laloo nto. Umosha ixesha. You are wasting the time. Usinya nako. Utlanga ngayi. Utlanga ngenkani. Anisidevi kahle Xitsonga, mara mabona masinilava kusivulavula kahle. Now uzazibonela ukuthi mawusifake phi esi-right nesi-wrong. Ndigqibile muntu ebendikuthetha. Anyway, anyhow, let's continue. Here's the story now. We are given a situation that m is the thing that it is, and 2, we need to find now the smallest value. So this is easy. We want the nth term itself in the sequence. We know that Tn is equal to ar to the n minus 1. This is what we know. But we don't need to write this down. I'm just saying it. All we need to do here is to write here that Tn to be less than 1 over, because this is what we are given, 6561, implies that ar to the n minus 1 must be less than this fraction. A very small fraction, by the way. Then we substitute the values that we are told. Of course, the first term is still 63. It's not going to change. But now r is a third. We found out, and somebody volunteered it to convince us that we are in the right path. Okay, very important stuff. Now, folks, we just simply divide by 63 so that we leave this power of base a third to the exponent n less than. Remember, we divided by a positive number, so this is not going to change. Now, when we divide by 63, this is as good as multiplying 63 to the denominator. Okay? So what I'm getting is a very ugly, lengthy expression. Is 41, 33, 43. Okay, very long. 413 scored, 33 and 43. You understand? Yes. Now the question is, can we express this power, this fraction, as a power of base 1 over 3? Raised to a particular exponent. Well, we know the gymnastic that we can perform. Now this is part of the rough work, please. It must not be a part of the solution. So we write 4, 1, 3, 3, 4, 3 equal. We get 4, 1, 3, 3, 4, 3. Then we hit shift and we then hit fact. And what do we get? 4, 1, 3, 3, 4, 3 equal to shift fact. Matata. We get 3 to the exponent 10 times 7. Oh, that hurts. Now this 7 is preventing us from doing the things that we want. So we can't express this as a power of base 1 over 3 raised to a particular exponent, because this 7 is a multiple, so that's a problem. Of course, there are many ways of dealing with this exponentially still if you are strong in doing exponents, but let's just leave this one. We are not going to benefit from doing that as yet. This highlights that we need to introduce logs, because we know our absolution here. To undo exponents, we must take the inverse operation. Now we introduce a log to this long leggy expression. Now, this also implies, now we're going to use essentially logarithmic rules now. So this is, n minus 1 times the log. I'm just going to prolong this, guys, for your benefit, because I know your algebra is weak. That's why you call maths a difficult subject. It's because algebraically you are challenged. You are disabled. I'm sorry, guys. I did hleki, but now, what do? We divide. Logs. We divide by log a third. Log of a third. But now remember, log of a number less than 1 greater than 0, because we cannot have a less than 0, is a negative number. So this is a negative number. Just remember this. This is a negative number. You can just do it on the calculator. You will see. We get a negative answer. Now, if we divide by a negative answer, what happens to the sign? It changes. So this means n minus 1 is greater than. Now I'm going to just jump. Remember, this becomes the base, this becomes the number. So I'm using 2 logarithmic rules at a go, because analysis lodlala, guys. So ixesha lodlala likho. Xa ungazazi logs ufile ke, right? Uyazi loo nto. Ngelishwa ngendikuncede ndikuxelele kodwa uba xa udivide ngalaa nto negative, so dividing by negative changes the sign. You should know this. Now we know that n minus 1 is greater than. Now we put it on the calculator because there's no guessing this. Okay? So log of a base 1 over 3. In fact, log of that number. Again, please guys, learn to read expressions. If we've got log like this is read as log of a to base b. That's how you read it. Don't read things. There's no log of a base here. The log is of a number, okay? We take the log of a number. We can adjust the base depending on what we want. So basically the base is a secondary issue here. It's an adjustment, but we're taking a log of a number. So don't read from the base to the number. No, 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 that's wrong, okay? So please, again, mathematical language, guys. This is a language, this thing. I know you treat it like it's some crazy gibberish issue of symbols and numbers. This is a language, and like a language, you just speak correctly if you're an academic or you're in school. But if you're at home, yes, you can talk nonsense. You can talk however you want. You can twist the terms. Sentences can be broken. We understand. You are not in that capacity where you can put things in a nice order so that everybody, including the educated and the uneducated, can follow you. Because when you're talking gibberish, or let me just say you talk carelessly or colloquially, you know, you can confuse an academic who's purely a fanatic. They'll be like, what are you trying to say? This is when they start saying, can you repeat that? And you're like, man, you heard me. What the hell? It's because you're talking something that is not making sense immediately to them, because there can be a lot of things you could be saying. But now when you say what you say, even a person who doesn't understand what you're talking about can actually follow you as well. So that's the essence of mathematical language. You must speak so as to be heard by anybody. All right, folks, let's do it. So we've got log to a... No. We've got log of the number, which is 1 over 413,343 to base 1 over 3. That's how you read it. Please, 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 how read like this, please. Ndiyakuxelela futhi ndiyakuxelela ndingxamile. Wafunda nje ezomqala akho. Ndiza kunyathela emqaleni. Uyiqonda le nto. Ndikunyathela emqaleni. So this is 11, comma. Let's just take to 3 decimal places. 771 here. This is just to protect the answer in case we need to. But again, this is a whole number, so we can already do 2 decimal places. Remember, that's the instruction. So when this is not going to affect that, we don't worry about it. So this implies still, now we transpose this. Now transposition doesn't change the sign. So this becomes 11 plus 1, that's 12,77. But remember, we are solving for n. So n cannot be an inequality, it has to be a value. Remember, we know that n is an element of natural numbers. Now, what is the number greater than? What is the next natural number greater than what we see is 13. Therefore, n is equal to 13. Nazok. Okay, guys, so this is important. This is important, okay? Now, what are we going to say? We can check this, you see. But now, where are we going to check it? We are going to check it here, provided our business is done correctly, right? Now, let's run the check. Of course, I'm just teaching you guys because we are at the end. I like to say I'm teaching, but I'm not a teacher. How ridiculous. How can someone who's not a teacher teach? I'm showing you guys. Yes, now I can show, because no matter what it is that I'm showing, I can show. Okay, mandinibonise again. Now, we take this left-hand side. We prove that this left-hand side is indeed less than the right-hand side. Right. Now, the left-hand side is going to be 63 into a third raised to exponent. Raised to exponent. Now, 13 minus 1. This is the same as 63 of a third to the exponent 12. Masibon, what is the answer then? 63 into 1 over 3 to the exponent. To the exponent 12. I am getting something like this. 7 over 59049. Okay, but now what was the other one? It was 1 over 6561, right? Now how will you know this one is bigger than the other? Because hey, sometimes it is Yahara-san. Now let's see. If this is bigger, let's take this and subtract that. If we get a positive answer, then indeed this value is bigger than that, right? Let's do it. So let's say 1 over 6561, and then sibulale leya. Yabona? Sibona ba iyabulaleka na okanye ibulaleki. Xa ingabulaleki sawubona ngo negative 59049. Yes, kuphuma answer a positive, so this means 7 over Sunhlanyisa, it means 7 over 59049 is definitely less than 6561, because kanthatha le fraction funeka nizazi izinto ezinto subtract leya. There are many ways of killing a cat, guys. I get a positive answer, and that means le iyakwazi ukubulala leya, le inamandla kunale. So ingenyaniso ke ngoku yanixelela le nto uba xa u-n ngu-13, definitely this expression is going to be less than that value. Hell yeah. So if beyingekho inyani buzathi xa uthatha le ubulala leya kuphuma negative, iyaxelela uba leya ibulaleki, iyaprevail. The sign of this number when it is negative will prevail to suggest that this is bigger, and that would mean our answer is wrong. So guys, learn to learn. Learn to learn from observation, okay? Because abantwana, as far as I know, Tato B.F. Skinner, the guy of behaviorism, bazafundisa psychology at university as one of the majors, especially teachers. I don't know why teachers are so bad, actually. Nina, hona le ntho ke sa itsebeng ka lona ka nnete le nga ile reng matitjhere hater was hate matitjhere ai matitjhere wa tseba lona matitjhere le anqaka ka nnete ha ke le tsebe hantle hobane le ya etsa psychology empa ha le khutla mana ha le sa itsebe le hore ntho ena ne le ibalela sekolong man. Psychology is to be studied so you can understand human behavior, especially for teachers, because human beings, like students, they are like animals, okay? They learn by observing the adult ones, and they try to imitate, although they'll try to test you along the way and see if you will respond or what will happen, because they have this exploratory nature of their minds. They like to explore. And they find out by testing the waters. Okay, I get punishment if I do this. I get, commended if I do that. So then it improves. That's what we call now reinforcements. Again, this is a situation that you will learn from Sigmund Freud, which comes out of operant conditioning. Now this is Benifuna ukuthi, guys, if you are a teacher and you display things to students, they will imitate you better, because when they do so, you will reinforce it with good marks and a commendation of some sort, or at least give them your approval. That's what makes students learn. Now all of a sudden teachers are careless. They just go around things randomly. They just drop numbers from the sky, and then they expect kids to be methodical. How on earth is that going to be? Because they do exactly what you do. You understand? If you are poor at reading questions, you just start answering. You don't emphasize the understanding of what is written and its significance. Then they will just do as you do, and that's why they get stuck, because you yourself as a teacher, you will get stuck. That's why you run away from questions that are difficult in class, because you don't show kids that questions like that can challenge you as well, so that they can understand that the challenge is for everybody. Now, I'm that type of a person who liked, when I was a student, of course, I would challenge myself in front of my peers, sometimes in front of our teachers when they give us a platform. Do a question I've never seen in front of everybody, so that I can learn to not take an embarrassment from failing to do something. Because that's another thing people don't understand. The temperament is something that you grow by learning to not be afraid of losing in front of everyone's eyes, who actually believed at first you were a genius and now all of a sudden you are not. People don't look at you that way. They understand, though, that even the best can be taken down. Even the mighty can fall. You understand? Again, you will understand why they fell. It's because of overlooking things, taking things for granted. All of those kind of things. Anyway, guys, the idea is check your answers, okay? If you are a teacher, you are in that habit. Students will do so, and they will fail to fail, okay? Because for me, as a teacher, your job is to make students to fail failing. They must actually fail failing by passing, because passing is actually failing to fail, isn't it? Yes. And again, the language, guys, if you are not fanatics of the subjects as you teach it, kids are going to learn the rubbish language most of you teach. I'm sorry to say it's rubbish, but it's absolute nonsensical. Okay, masingayapo, it's controversial. But here's the other thing, guys. Okay, masingayi extend. This hour of exploration is over, because we are convinced our answers are correct. So we were scoring some easy 9 marks, but I guess the last 5 was a bit challenging for a student who doesn't know their work. First of all, these substitutions here are important, because we needed them, right? Right. But now, when we ended up here introducing logs, introduction of logs is not really an application per se, but here, knowing that we can drop the exponent to multiply to the log, that's number 1. Number 2, this is yet another law or rule of sorting up logs. And of course, the sign change, because knowing that the sign is going to change is key. Because remember, you look at the marks, you will see that there's no way I can get 5 marks by just substitution and then answer. No. And we get our answer there. Can you see we have 5 marks? 1, 2, 3, 4, 5. Indeed, siyabangena. And sesibangenile, sesingaphakathi, sesiyagoqoza. I am sorry if you feel offended by my commentary. My commentary, guys, remember, it's harmless. It's just my stupidity showing out into the world. Okay? All right. But in life, I have learned that someone was talking nonsense. There's some very important 2 words that can transform your life. So pay attention even to that nonsense. You will be surprised how far it can take you. Anyway, guys, this is it for sequences and series for this video. We have exhausted our hour of exploration. I tried to go easy by not rushing anything, so that you understand every step, so that we can move on nicely. So guys, enjoy the video, and please re-practice these questions so that you can make your own realizations on top of my own. That means you are adding more and more solidity to your understanding. And I can assure you, no matter what question comes in the exams, you will be able to beat it to the ground. Otherwise, I'll see you again next time. Goodbye.